Hello everyone, welcome back. And today in today's class we'll be covering this one important chapter of class 10 ICSE, that is electrolysis. This chapter is extremely important and it carries a heavy weightage for your board exam also. So we are going to be quickly seeing and looking at this chapter, and we are going to be going through everything that is in this chapter. So let us begin. So I want you to sit down with a paper and pen and probably make short notes with me, so that after a lot of time also you remember. So the chapter is electrolysis. Okay, first let's see what is this term. What is electrolysis exactly? So electrolysis, this is a pen too small. Let me just increase the width. We'll be going with a ball pen only. Yeah. So what is electrolysis? It is the process of decomposition. Please pay attention on the keywords. It is a process of decomposition of a chemical compound. ऐसा वैसा chemical compound नहीं, ऐसे भी मैंने किसी भी कंपाउंड को लिया उसको डिकम्पोज कर दिया. इट्स नॉट लाइक दैट. इट इज़ द प्रोसेस ऑफ डिकम्पोजिशन ऑफ अ केमिकल कंपाउंड इन इट्स एक्वियस, यानी पानी में घुल के जो डिजॉल्व सोल्यूशन बनाते हो, एक्वियस सोल्यूशन. और नहीं तो हम उसे मेल्ट कर सकते हैं. इट्स molten state. So it is the process of decomposition of a chemical compound in its aqueous solution or in molten state, accompanied by a chemical change. यहाँ पे सिर्फ डिकम्पोजिशन नहीं होता, एक केमिकल चेंज भी होता है. तो डिकम्पोजिशन itself is a chemical change, right? But it's accompanied by a chemical change by using direct current. If there's a question like what is electrolysis and you use this definition for 2 marks, then you are getting 2 out of 2. So what are the keywords? Let me just underline for you. Yeah, with a buttercup yellow. Yeah, so it's the process of decomposition. It's the process of decomposition of a chemical compound in its aqueous solution. What is electrolysis? Electrolysis is the process of decomposition of a chemical compound in its aqueous solution or in the molten state, accompanied by a chemical change by using direct current. Okay, so what is electrolysis exactly? Electrolysis is a process, okay, repeat with me. Electrolysis is a process of decomposition of a chemical compound in its aqueous solution or molten state, accompanied by a direct change, or you can say accompanied by chemical change by using direct current. Again, what is electrolysis? Electrolysis is the process of decomposition of a chemical compound in its aqueous solution or molten state, accompanied by a chemical change by using direct current. That is for the definition of electrolysis. All right, now let us quickly look at what is, after electrolysis, what is electrolyte. These are some common definitions. Electrolyte की definition directly it will never come, but मैं आपको बताती हूँ. Electrolytes are those compounds which in their aqueous or molten state, compounds which in their aqueous or molten state allow electric current to pass through them. इसका मतलब क्या है? वो ऐसे कुछ केमिकल कंपाउंड्स होते हैं जिससे अगर उसके एक्वियस और मोल्टन स्टेट में उसे आप करंट पास करवाते हो तो उसका ब्रेकडाउन जो होता है, करंट का ब्रेकडाउन, ये अलाउ करता है. ओके, so that is it. The compounds, the chemical compounds which allow in their aqueous or molten state, they allow the passage of electric current through them. ठीक है, that is the entire concept of electrolyte. And what is electrolysis? It is a process of decomposition of a chemical compound in its aqueous solution or its molten state, accompanied by a chemical change by using direct current. तो ये हमें याद रखेगा. चलो. Now let's quickly do one thing. Let's go over हमें पता चल गया इलेक्ट्रोलाइट क्या है, ये पता चल गया। इलेक्ट्रोलाइट के कुछ एग्जांपल्स देख लेते हो। देखो 2 टाइप्स के इलेक्ट्रोलाइट्स होते हैं। ऑल एसिड्स बेसिस सॉल्ट्स जो भी completely ionizable है, द ones which can completely be ionized। जो partially ionized होते हैं वो उसे कहते हैं weak electrolyte, जो complete ionized होते हैं उसे कहते हैं strong electrolyte। एसिड में आपके इलेक्ट्रोलाइट आ जाते हैं H2SO4, HNO3, H3PO4 वगैरह वगैरह। ये देखो ये बहुत स्ट्रॉन्ग एसिड्स है। अगर आप एसिड स्ट्रॉन्ग हो, अगर आप बेस स्ट्रॉन्ग हो, तो आप इलेक्ट्रोलाइट भी स्ट्रॉन्ग हो, क्योंकि आप बहुत अच्छे तरीके से डिसोसिएशन जो कर सकते हो, इसलिए आप स्ट्रॉन्ग इलेक्ट्रोलाइट हो ना भाई। तो एसिड्स में ये सारे आ गए। बेसिस में आपके जो स्ट्रॉन्ग बेसिस है NaOH, KOH। बट उसके बाद देखो कुछ वीक भी बेसिस है, जैसे मैं दिख रही हूँ भी NH4OH एंड CaOH2। तो ये जो है आपके वीक बेस तो है ही, उसके साथ साथ ये वीक इलेक्ट्रोलाइट भी है। इफ़ यू स्टडीड चैप्टर्स 3, यहाँ पे लिखा हुआ है कि ये जो 2 बेसिस है अमोनियम हाइड्रोक्साइड एंड कैल्शियम हाइड्रोक्साइड, ये वीक एल्कलीज है। ये एल्कली है बट वीक है, ठीक है। मतलब दे पार्शियली आयोनाइज व्हेन डिजॉल्व्ड इन वाटर, ठीक है। समझ में आ गई बात। अच्छा, सॉल्ट्स में से कौन कौन से इलेक्ट्रोलाइट्स बनेंगे? NaCl, फिर CuSO4। CuSO4 का जो एग्जाम्पल है वो है एंड मोल्टन PbBr2, ओके। जो लेड ब्रोमीन है उसका भी हमारे पास एग्जाम्पल है, हमें स्टडी करना हमारे सिलेबस में है। PbBr2 का इलेक्ट्रोलाइटिक डिसोसिएशन, CuSO4 का भी है, ओके, एंड डिस्टिल्ड वाटर का है। अब देखो इलेक्ट्रोलाइट्स जो होते हैं, दिस इज़ अ ब्रॉड टर्म। इलेक्ट्रोलाइट काफ़ी बड़ा सा एक ब्रॉड सा टर्म है एंड इसको हम 2 हिस्सों में बांट सकते हैं। इलेक्ट्रोलाइट को हम 2 तरीक़ों के बोल सकते हैं। व्हाट आर द तरीकाज? लेट मी जस्ट टेल यू। फर्स्ट वन इज़ weak electrolyte and second one is strong electrolyte, ठीक है। इनमें आप अगर डिफरेंस जानना चाहो तो these are the differences quickly I'll be discussing. They partially ionize. Number 1, partially ionize in fused or aqueous state। ये क्या करता है? completely ionize, complete ionization होता है, complete dissociation होता है। आप बता सकते हो complete dissociation। ये partially dissociate या ionize करते हैं, completely dissociate हो जाते हैं, complete dissociation, ओके। कंप्लीट डिसोशिएशन, यहाँ पे भी लेट अस राइट डिसोशिएट, कंप्लीट डिसोशिएशन इन फ्यूज्ड और मोल्टन स्टेट। अच्छा, दीज हैज़ मॉलिक्यूल्स एंड आयन्स, इनमें दोनों ही होते हैं, मॉलिक्यूल्स भी होते हैं, आयनाइज भी होते हैं। आयनाइज किए हैं बट उतने ज़्यादा आयन्स भी नहीं है, इनमें सिर्फ और सिर्फ आयन्स पाए जाते हैं, ठीक है, ओके। गुड कंडक्टर्स ये पुअर कंडक्टर्स होते हैं, पुअर कंडक्टर्स, और ये गुड कंडक्टर्स होते हैं, गुड कंडक्टर्स, okay। These are the good conductors of electricity, these are the poor conductors of electricity, okay। These have only free mobile ions, these contains ions as well as molecules, they partially dissociate in fused or aqueous solution, they completely dissociate in fused or aqueous solution, and they do not allow a lot of current to pass through them, so small amounts of electricity, small amounts of electricity to flow through them, and they allow large amounts of electricity to flow through them। ठीक है, आपको अब ये समझ में आ गया क्या क्या मेन डिफरेंसेस हैं। अब देखो इसमें वीक इलेक्ट्रोलाइट्स के खाते में कौन कौन नाम लिखा के आ रहा है। H2CO3 कार्बनिक एसिड, एसेटिक एसिड, ऑक्सैलिक एसिड इज ऑल्सो देयर। बेसिस के अंदर अमोनियम हाइड्रोक्साइड, कैल्शियम हाइड्रोक्साइड, ठीक है, ये सारे हैं। सॉल्ट्स के अंदर वी हैव अमोनियम कार्बोनेट एंड लेड एसिटेट, ओके, अमोनियम कार्बोनेट तक रखते हैं यहाँ पे हमारे पास NaCl है, PbBr2 है, जिसके बारे में हम ऑलरेडी बात कर चुके हैं, PbBr2, CuCl2, CuSO4, ये सारे। नाउ कम टू व्हाट इज अ नॉन इलेक्ट्रोलाइट। नॉन इलेक्ट्रोलाइट अब क्या होता है भाई, ये से वीक इलेक्ट्रोलाइट्स जो होते हैं, they allow small amounts of current to pass through them. Strong electrolytes allow large amounts of current to pass through them. Non-electrolyte do not allow electric current to pass through them. ठीक है, इन aqueous state में भी या molten state में भी, कैसे भी state में हो, they will not allow electric current to pass through them and it does not decompose at the electrodes. Okay, so they have no ions, no molecule, they have no ions, okay, they have only molecules. So one important concept is, number one, strong, we are talking about electrolytes here, weak and non. Right, किसमें क्या है, strong में ions only, weak में molecules plus ions, एंड नॉन में मॉलिक्यूल्स ओनली। इस कॉन्सेप्ट से देयर हैज़ बिन अ क्वेश्चन, दैट इज़ द लास्ट क्वेश्चन आई थिंक PH दिया गया था। दिस कॉन्सेप्ट, दिस इज़ द वन कॉन्सेप्ट एंड दिस वन कॉन्सेप्ट, ऑल स्ट्रॉन्ग एसिड्स एंड स्ट्रॉन्ग बेसिस, जिन एसिड्स को हम स्ट्रॉन्ग बोल रहे हैं, जिस बेसिस को हम स्ट्रॉन्ग बोलते हैं, आर स्ट्रॉन्ग इलेक्ट्रोलाइट्स। ये स्ट्रॉन्ग इलेक्ट्रोलाइट्स भी होते हैं। स्ट्रॉन्ग बेसिस, स्ट्रॉन्ग एसिड इक्वल टू स्ट्रॉन्ग इलेक्ट्रोलाइट। इन दोनों कॉन्सेप्ट से मिला के लास्ट क्वेश्चन बना है 2026 के बोर्ड के पेपर का, राइट। इन कॉन्सेप्ट को मिला के PH दिया गया था एंड दीज क्वेश्चन वर आस्क्ड कि आयंस किस में है, ठीक है। PH से आपको पता चल रहा है कि कौन सा वाला स्ट्रॉन्ग एसिड है, कौन सा वाला स्ट्रॉन्ग बेस है, फिर यहाँ से आप अंदाज़ा कर सकते हो, राइट। ये कॉन्सेप्ट, ये दोनों कॉन्सेप्ट्स काफ़ी इंपॉर्टेंट हैं। ऑल राइट, नाउ लेट्स कम टू एग्जाम्पल्स ऑफ नॉन इलेक्ट्रोलाइट्स। क्या क्या हो सकता है, डिस्टिल वाटर, अल्कोहल, केरोसिन, कार्बन डाइसल्फाइड, these all. Now acids, bases, salts, all salts are strong electrolyte as I told you, but yes, mercury chloride, ammonium carbonate, these are not, the lead acid, these are not good electrolytes, by the way. Now let me show you examples of dissociation or electrolytic examples of ionization or electrolytic dissociation of certain acids, bases and salts. तो first हम ना एक table बना लेते हैं. So what we'll do is we'll basically try just okay, let me just tell you. Okay, yes, all salts are strong electrolytes. They form acidic or basic or neutral solutions after complete dissociation. Some salts are generally more volatile than the other ones, and the salts which do not dissociate can be considered as weak electrolytes as compared to other ones. So if you are asking me what are some weak electrolyte salts, weak electrolyte salts, they are mercury carbonate, HgCl2, and ammonium carbonate. These two are weak electrolyte salts. Okay, now let me come to a chotu piddu sa topic, that is what is an electrolytic cell. Quickly I will just explain what is an electrolytic cell, also called a voltameter. So basically a non-conducting vessel containing two electrodes. So number one point is there are two electrodes in a non-conducting kind of vessel, and there's a solution of electrolytes used to bring about a chemical reaction. So basically what is an electrolytic cell? It's a non-conducting vessel of two electrodes immersed in a solution of electrolytes used to bring about a reaction. And electrolytic cells require an outside source of electricity, which is always a DC source, yani direct current source. Why do we not use AC and we only use DC? That is also a thing that will be clarified. We will also discuss that. That's also for a reason. And what is the energy conversion here? The energy conversion that's happening here is electrical to chemical. Electrical energy to chemical energy is the energy conversion that happens in an electrolytic cell or a voltameter, right? So let me just write this cleanly. If you want, you can access these notes. These will be very helpful for you. So a non-conducting vessel that contains two electrodes. So what is an electrolytic cell? It's basically a non-conducting vessel that contains two electrodes, and the two electrodes are immersed in a solution of electrolytes used to bring about a chemical reaction, receiving its outside source of electricity from a DC source to initiate the movement of ions. So the current is actually being carried by these ions between two electrodes where the chemical change takes place. If I want to draw the diagram, let me just draw a quick small diagram over here. Just wait. Okay, no, this is not the shape I was going to draw. This is definitely not the shape I was going to draw. So just let me make a box. Not happening. Yeah, let me make a box, and there on the top, say I have this chotu sa diagram I'm showing you. Okay, here I have my electrolyte filled to the brim. Here I will have my two electrodes. Okay, this one is, say, my anode. Let me make it bigger. This one is my cathode. Okay, and I have a battery and I have a source here. Sorry, I have a battery here. These are my two electrodes. This is my anode, this is my cathode. Okay, and I have my source here. Yeah, this is my positive terminal, this is my negative terminal. This is the anode. This is the cathode. This is the electrolyte. This is basically how a voltmeter looks like, and this is my battery. This is basically how a voltmeter looks like. So far we have made these notes, very important. These are the basics. Now let me quickly show you what an electrochemical cell is. Okay, electrochemical cell. Electrochemical cell, simply, it's a device that's used to convert this chemical energy. This is electrical energy to chemical energy in an electrolytic cell. This is my chemical energy into electrical energy. There are some important examples that you must know about. These are basic topics, doesn't even come in the exam most frequently, but then just cover it. Simple voltaic cell, Daniell cell. Okay, so electrochemical cell is basically, very simply, just a device that's used to convert the chemical energy into the electrical energy. Now let's come to what are electrodes. These are some terms that you are getting habituated with so that we can discuss the examples better. So what are electrodes? Two metal plates or wires or graphite rods or gas carbon rods. Okay, so two metal plates or wires or graphite rods or gas carbon rods. Two metal plates or wires or graphite rods or gas carbon rods immersed in the electrolyte through which the current enters and leaves the electrolytic cell are called electrodes. What did I just say? So let us just highlight what are the important points over here. Very, very important to highlight all the important points over here because very important place also this is. So two metal plates. आपको पहले ये mention करना है. There are two. Okay. So two metal plates or wires or graphite rods or gas carbon rods which are immersed in the electrolyte through which the electric current enters and leaves the electrolytic cell. जो electrolytic cell होता है उसे enter and leave करता है. That like the voltmeter, right? That is basically what is called the electrodes. So now we have understood the definition of electrodes, electrolytic cell, electrodes, okay, then electrolyte. Now, there are two kinds of electrodes. What are the two kinds of electrodes? There are two kinds of electrodes. One is anode. Anode is the positively charged electrode. Attracts anions. Anions तो negative है ना? Anode तो positive है तो obviously positive negative को attract करता है. And we have the cathode. That is a negatively charged and attracts cations which are basically positively charged वैसे तो they get attracted to the positive but negatively charged, right? So the one that's connected to the positive terminal of the battery is anode and the one connected to the negative terminal of the battery is cathode. When the current is turned on, the electrons actually flow from the anode to cathode. तो electrons का flow कैसा होता है? Electrons का flow होता है from anode to cathode, right? So that is why the cathode becomes a negative electrode by which the electrons enter the electrolyte. So basically the cathode is the one through which the electrolytes are basically enter the electrode, negative electrode, okay? So cathode becomes a negative electrode by which electrons enter the electrolyte and anode becomes a positive electrode by which electrons leave the electrolyte, okay? After that, let's just discuss some differences between anode and cathode. Anode and cathode. Anode is a positive electrode that's connected to the positive terminal of the battery. Cathode is a negative electrode that's connected to the negative terminal of the battery. Anions migrate to the anode. Cathode migrate to the cathode. Okay, let me just differentiate quickly between an anode and cathode. Oh my god, this is huge. Yeah, that's fine. Anode यहाँ पे है, cathode यहाँ पे है. Connected to positive terminal of battery. I'm just writing in short. Connected to negative terminal of battery. Okay. Anions migrate to anode. Cations migrate towards cathode. Okay. This is the oxidizing electrode. क्योंकि यहाँ पे ऑक्सीडेशन होता है by loss of electrons. Oxidizing electrode, and this is the reducing electrode, right? So that's basically far and more the difference between them. Now what are ions? We all know atoms or groups of atoms carrying a positive and negative charge as a whole. Okay, then let's come. The charge of an ion is also the valency of the ion. Now I'll just tell you the basic difference between a cation and an ion. Cations are basically positively charged ions while anions are negatively charged ions. Cations migrate to the cathode during electrolysis, and during electrolysis the anions are the ones which migrate towards the anode, okay? And cations, they gain electron to become to form the cathode, okay, from the cathode. So what do cations do? Cations gain electron from the cathode. जो cathode होता है ना आपका, जो cathode होता है वहाँ पे जाके cation क्यों जाता है? वहाँ पे stable होने के लिए जाता है, right? Stable होने के लिए उसे क्या चाहिए? Electrons चाहिए, क्योंकि वो electron दान करके बैठा हुआ है. So they gain electrons from the cathode and get reduced to become a neutral atom. और वहाँ पे क्या होता है? They lose electrons to the anode to become a neutral atom, ठीक है, to get oxidized and to become a neutral atom. Anions lose electrons to the anode and get oxidized to become a neutral atom. Now let's come to oxidation. So in electronic concept, what is oxidation? What is reduction? Oxidation can basically be defined as three things. Number one is addition of oxygen. Number two is removal of hydrogen. Number 3 is removal of electron. On the other hand, there is reduction. वहाँ पे भी आपके 3 points में reduction कब लिख सकते हो? Removal of oxygen, addition of hydrogen, right? Addition of hydrogen and addition of electron. So these is basically essentially the difference between a oxidation and reduction. Not that big of a concept, also very easy concept, you can learn it quickly, easily. Okay. Addition of oxygen is also a chemical process. Okay, removal of hydrogen, oxidizing agents are also there. Then solids, yeah, that is all there. Okay, now we will go to this. In your book, you will see that there is something called theory of electrolytic dissociation, but you do not have it in your syllabus, so I'm not covering it. Then you have conduction in compounds. That's what I said. They're electrovalent or ionic compounds. They consist of aggregate of oppositely charged ions held in their positions by some strong electrostatic forces of attraction. Okay. So, in solid state, electrovalent compounds like sodium chloride, they can also not conduct electricity despite the presence of ions. And for electrolyte compounds, when they are melted or when they are dissolved in water, the forces of attraction between them are broken. They weaken and they are broken, and the ions move about and they conduct electricity. Well, this is also not there. That is what is the characteristic of electrolysis. So, I will not do it with you. Direct, we will come to electrolytic dissociation of sodium chloride. That's what we will be coming to right now, because it's a long chapter. It's one of the longest chapter. There are 3 extremely long chapters. Organic is the longest, definitely, but these are a few challenging chapters. Electrolysis, then we have metallurgy, and then we have mole concept, and then organic chemistry is also there. So these are the challenging, or you could say the long chapters. The ones are quite easy, relatively easy. So we've already made a lot of notes. I would like it if you have written down all of them. Okay, now let's come to electrolytic dissociation. What exactly can we say is electrolytic dissociation? Electrolytic dissociation. Okay, the process due to which an ionic compound dissociates into ions. The process due to which an ionic compound dissociates into ions. The process due to which an ionic or an electrovalent compound dissociates into ions in its fused state. The process due to which an ionic compound dissociates into ions in the fused state or in aqueous state, either fused state or aqueous state solution, or you could say like aqueous solution or aqueous state. The process by which an ionic or an electrovalent compound dissociates into ions in its fused or aqueous solution state is called electrolytic dissociation. And you know the drill, I always will highlight the points. So the process due to which electrovalent compounds or ionic compounds, dissociates into ions in its fused state or in its aqueous solution is called electrolytic dissociation. Pura cheese is very important. Now let's come to the electrolytic dissociation of sodium chloride. Electrolytic means the process of dissociation of the electrovalent compound into ions when it's fused to a molten state is called electrolytic dissociation. So electrolytic dissociation of NaCl, obviously it's fused or in its molten state. Right, now see, sodium chloride, it's an ionic compound, it's an electrovalent compound, and its crystal structure, it contains Na plus and Cl minus. In the solid state, sodium and chloride ions, they are not free, but they are held together by strong forces called electrostatic forces. Now, if I just want to draw Na plus quickly, how will I draw it? Na plus, and we'll have Cl minus, right? This will be the thing, and electrostatic attraction will also be there. So this is basically the structure of what? Structure of sodium chloride, like, and they are held closely by electrostatic forces, but when they're in their molten state, these ions become an aqueous or molten state. Na plus and Cl minus are free. These ions are free, they are ready. Okay, so when sodium chloride is dissolved in water or it's melted in the aqueous solution, the slightly negatively charged oxygen atoms of the polar water exert a pull on the positively charged ions. Okay, so we have the water also, which is a polar covalent compound, and there are slightly negative, the water is a covalent compound, and water develops a partial charge, right? So it has like a delta positive charge, and this has a delta negative charge. This is due to charge separation in water. So that's what, like, functioning happens in water. Okay, that's how it works for water, which we have also studied in the self-ionization of water. So these slightly, the positively charged hydrogen atoms, they are attracted towards the negatively charged chloride ions, and the negatively charged oxygen atoms, they are attracted towards the sodium atoms. Thus the ions become free in solution. This is also due to the polar protic nature of water, and the high dielectric constant of water. Very, very important key terms, two key terms which are really important: polar protic and high dielectric constant. That's why, there are questions like, why do you think electrovalent compounds break down in water? This is basically the reason. In molten state, the high temperature required to melt the solid weakens, and the bond between the two particles are free. Okay, now let's come to ionization. Dissociation is basically, the electrolytic dissociation is the process in which, the process by which ions, these electrovalent compounds or ionic compounds, they dissociate into ions. In their aqueous solution or molten state. Now let me come to what is ionization. People often confuse between dissociation and ionization, but they're different. Ionization is the process. This is not for, in the case, ionization never happens in electrovalent compounds. The process, or you could say, by which there are only certain compounds which exhibit ionization. The process, and these compounds are your polar covalent compounds, right? So they have a partial positive negative charge, so they are the ones which make ions. In electrovalent compounds, there are already ions are there. What the ions have to do is just the very strong bond between the ions needs to break, and that's it, they're free. But for the case of polar covalent compounds, they need to make the ions. Okay, so the process by which polar covalent compounds are converted into ions, they are actually converted into ions, whereas in dissociation, the ions which are already present, the bond between them is weakened, and then they are getting out. But here, the process by which polar covalent compounds are converted to ions in water is ionization. Right, these are also the key terms. Polar covalent compounds converted into ions in water is called ionization. Now see, this one example is seriously HCl, very good example. HCl, if you keep it in water, it will discharge into H plus and Cl minus ion. Okay, that is your hydrogen ion and your chloride ion. because HCl वैसे तो it has a charge like H this, and this has a partial negative charge. Hydrogen has a partial positive charge and this has a partial negative charge. So this is the dissociation what happens in HCl. So if you just want to see, this happens when I add H2O in it. Okay. So what is the difference between ionization and dissociation? Ionization is the process where, there is a formation. There is a formation of positively or negatively charged ions from molecules which are not initially in the ionic state. You have to understand that these molecules, HCl, this is initially not in the ionic state. Not in the ionic state initially. But the process of conversion of the molecules into ions, okay, that is ionization. But what is dissociation? Dissociation is basically the separation of ions which are already present in the ionic compound, while ionization is the formation of positively or negatively charged ions from molecules which are not initially in the ionic state. And ionization, only polar covalent molecules show ionization. For dissociation, electrovalent compounds show dissociation. Okay, that is it. Okay, fine. Now let's come to, this is done. Now let's come to another important topic. By as far as these are the notes that we've already made, and that's a lot of stuff that we've already done. So I want you to please focus and make notes along with me, which I've already making, and please access these notes once the lecture is over. They are going to be very, very helpful for you. Now let's come to another very, very important topic, which is called electrochemical series, or it's also called EC series. Okay, so electrochemical series, what happens in the electrochemical series is, we all know that metals have a tendency to, if you are looking at a metal, then we know that it will lose electrons. Metals have a tendency to lose electrons, and the metals which have a very high tendency to lose electrons, they are termed as more reactive metals. They are very reactive metals, right? And they are placed at the top of the electrochemical series, in the reactivity series, and they're always, very excited to lose their electrons from the outermost shell of the electrons, and they want to form positive metallic ions forming cations. For example, say K always wants to, it has one electron in its outermost shell, it always wants to lose that one electron and it wants to become K plus. Na also, it wants to lose that one electron and become Na plus. Then let's talk about Ca. Ca wants to lose those two electrons to become Ca2 plus. Okay, Mg also. Mg wants to lose those two electrons, becoming Mg2 plus. Right? And they all want to become cations. What are these? These are all cations. Okay. However, then another example, Al. Al also wants to lose those 3 electrons to become Al3 plus, and all of them are cations with the valency, whatever is in the charge. However, the tendency to lose these electrons varies from metal to metal. The tendency to lose electrons varies from metal to metal, and that's how the electrochemical series is actually arranged. That is how it is arranged. Okay. Well, now that we have done this much, let me again continue. So what is electrochemical series? Na gets converted to Na plus, and much more easily. Okay, so conversion of Na to Na plus is much more easier than the conversion of Cu to Cu2 plus, or Zn also same way, it loses 2 electrons to become Zn2 plus. But this, it's not easy. We've already read about the concept of electronegativity. We have read about the concept of ionization enthalpy. These people, they are ionizing, right? And ionization enthalpy, copper has a higher ionization enthalpy, means it requires more energy to be converted into an ion. Okay, so zinc also converts into a zinc ion easily than Ag will lose 1 electron. Ag has to lose only 1 electron to convert to Ag plus, right? And Zn has to, on the other hand, has to lose 2 electrons to convert to Zn plus, 2 plus. But this is easy. Why? Because Zn as a metal, it has lower ionization enthalpy. Okay, it requires less energy to ionize and form an ion. Now, if I'm talking about the reactivity series, in an order we have what? We have potassium, we have sodium, calcium, potassium, sodium, calcium, then magnesium, aluminum, zinc. These are the top ones, right? And they also form their own cations. Now, about the electrochemical series, we all know that the metal with the higher position in the series will displace the one with the lower position. And after Pb, we have H, after which we have Cu. And all the metals which are below hydrogen in the electrochemical series, for example, copper, then you know silver, then copper, silver, all these, right? Mercury, copper, silver, mercury, gold, platinum. Gold and platinum are absolutely inert, but even copper, silver, mercury, these also, they cannot displace hydrogen from any acid. Okay, metals below hydrogen, very very important is metals below hydrogen. Metals below hydrogen, that is copper, Ag, Hg, Pt, Ptau, NuA, they are inert, cannot displace, they cannot displace hydrogen from acids. But look, the ones which are above hydrogen in the electrochemical series, for example, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, all these, they, lead, nickel, okay, they can actually displace, they can displace, but these cannot displace. Okay, okay. Anions, there we all know that they're the negatively charged ions. Now we have already read about this, but do you know about the electrochemical series of anions? We don't, right? So let me quickly give you a heads up about the electrochemical series of anions. These are the electrochemical series of cations, and we know it, right? We know about it, but electrochemical series of anions, we don't know about it. And this is basically the increasing ease of discharge at cathode. जितना जो कम रिएक्टिव होगा, जितना जो मेटल कम रिएक्टिव होगा, उसका जो कटायन है, easily it will be discharged. This is also the concept on which preferential or selective discharge of ions and electrode is based on. Okay, so see, when two or more, say there are two positively charged or two negatively charged ions, same charge के दो या दो से भी ज़्यादा ions, they are present in the electrolyte, but there's only one will get discharged. What am I saying? Can you understand? Even though there are, you know, say two like charged ions in the same electrolyte, same solution of electrolyte, under identical conditions, and are competing for discharge, they have a competition. Okay, they have a competition for discharge in the same electrode, only one of them is selected, and they have a rule also. So whichever anion is less reactive, whichever cation is less reactive, they will preferentially get discharged first. Okay, so if I have SO4 2 minus and if I have OH minus, who will get discharged? It's hydroxyl ion which will get discharged. Why? Because hydroxyl ion is above. Let me just show you the order. It's okay, not in this color, maybe this one. SO4 2 minus, we have 4, this is an order. Okay, then we have NO3 minus, then we have Cl minus, then we have Br minus, I minus, that is your iodine. Okay, I minus, then OH minus, sulfate, nitrate, chloride, bromide, iodine ion, and hydroxyl. This is the increasing ease of discharge. Increasing ease of discharge. This one I'm not writing. This also, below as you go, there is an increasing ease of discharge. Increasing ease of discharge. So the one who is below will get more easily discharged. This is all I was going to discuss about. You know, I was going to say about preferential. No, spelling galat likh di maine. Preferential. No. Preferential or selective discharge of ions. So when there are two or more like charged ions, two or more likely charged ions, right, they are present in an electrolyte, in the solution of an electrolyte under identical conditions, one of them will get selected, gets discharged. And how is it selected? Who will get discharged? How is it selected? So it depends upon three things. Number one is relative position of ions in the electrochemical series. So first the EC series, आप कितना नीचे हो, The one at the bottom, the one who is lower in the electrochemical series of anions or in cations, they will first get discharged as a preference. Then relative concentration of ions, किसमें ज़्यादा ions है, relative concentration of ions, and nature of electrodes, right? Look, the relative position of ions in the electrochemical series, if all the other factors are constant, see, if the concentration is say same, nature of electrodes is same, then any ion that is lower in the electrochemical series will get discharged first at the relevant electrode in preference to above it. For example, in the electrolysis of copper sulfate solution, say when we are discussing the electrolysis of different solutions, right, we will be set to write a few things. That is, number one, we will be set to write the ionic equation. You know what is the ionic equation? Copper sulfate, it gets discharged to Cu2 plus and SO4 2 minus, and then there's water also because it's a copper sulfate ka aqueous solution, that gets discharged to H plus OH minus. So I can see that there's two anions are there and two cations are also there. Now the thing is, which one will get discharged at the let's say at the anode, in दोनों anions में कौन सा वाला discharge होगा, कौन सा वाला नीचे है ज़्यादा, OH minus नीचे है, so OH minus will be the one getting discharged. So the cations, what do we have? Cu2 plus and so the second one you'll be asked to write cations present in the electrolyte right now, Cu2 plus and H plus. Then you'll be asked to write anions present in the electrode right now, and you'll write SO4 2 minus and OH minus. Now at cathode and at anode. एट कैथोड क्या होगा, कटायन जाएगा हमारा, कटायन ये दोनों हैं, इनमें से डिस्चार्ज कौन होगा, देखो दोनों ही माइग्रेट करेंगे, Cu2 प्लस एंड H प्लस migrate towards cathode because both of them are cations, so both will migrate towards the cathode, but Cu2 plus, but इसमें से नीचे कौन है ज़्यादा, Cu2 plus being lower in the EC सीरीज, इलेक्ट्रोकेमिकल सीरीज में, क्योंकि Cu2 प्लस लोअर है, दोनों ही जाएंगे, बट Cu2 प्लस डिस्चार्ज होगा. ओके, सो Cu2 प्लस का क्या होगा, Cu2 प्लस को ये हम अलग पेन से लिखते हैं, लेट्स टेक अ रेडिश ब्राउन पेन, या सो Cu2 प्लस विल एक्चुअली gain 2 electrons and it will become Cu. Okay. Okay, then let's come to वो at cathode हो गया, at anode SO4 2 minus and OH minus migrate towards anode, दोनों ही ions migrate करेंगे towards anode, but OH minus being lower, क्योंकि OH minus lower है इलेक्ट्रोलाइसिस सीरीज में, हमें अभी देखा ना, देखो OH माइनस लास्ट में है, सो वो 2 प्लस एकदम फर्स्ट में है, तो क्योंकि OH माइनस लोअर है, इट विल गेट डिस्चार्ज, तो जो जितना नीचे है इलेक्ट्रोकेमिकल सीरीज में वो उतना पहले डिस्चार्ज हो जाता है. ठीक है, दिस लेट मी राइट विथ येलो, OH minus will gain what am I writing? So will, अरे बाप रे, तो discoloration ही हो गया. Yes, now let me go back. Yes, so at anode what will happen, OH minus will get discharged, so OH minus minus 1 electron because it had already taken up 1 electron, so give it back. OH minus 1 electron will be OH, and since OH cannot be alone, right, we will have OH plus OH, H2O, and एक तो O बचा रहेगा, O भी अकेले नहीं रह सकता, तो O plus O give me O2. फुल रिएक्शन एनोड का फॉर CuSO4 का डिसोसिएशन. CuSO4 का हमने ऑलरेडी डिस्कस कर लिया, रिविजन में फिर से हम डिस्कस करेंगे इसे, बट दिस इज बेसिकली व्हाट हैपेंस फॉर CuSO4 का डिस्चार्ज. लेट मी जस्ट quickly write keys. This we have discussed CuSO4 solution, electrolysis, full details. So आयनिक इक्वेशन क्या है? CuSO4 breaks down to Cu2 plus SO4 2 minus, H2O breaks down to H plus and OH minus. In the cations present are Cu2 plus and H plus, and the anions present are SO4 2 minus and OH minus. At cathode, both Cu2 plus and H plus go and migrate, but since in the electrochemical series Cu2 plus is lower, that is why that gets discharged and Cu2 plus gains 2 electrons to become Cu. And at anode, what happens is both sulfate ion and OH minus ions they migrate, but then what happens is OH minus ion getting lower, it's lower, right? So it gets dissolved. Okay, so this is also called the spectator ion, क्योंकि ये कुछ नहीं करता, बस आके spectate करता है, यानी देखता रहता है. So spectator ion कहते हैं ऐसे. Okay, yeah, I hope you got it. The OH minus electron will get OH plus OH, H2O plus O plus O, O2. That is it. Now coming to the second point, that's concentration of ions. हमने क्या बताया? पोजिशन इन इलेक्ट्रोकेमिकल सीरीज, कॉन्सेंट्रेशन ऑफ आयंस, नेचर ऑफ इलेक्ट्रोड्स. कॉन्सेंट्रेशन ऑफ आयंस में क्या होता है? देखो, इफ एन इलेक्ट्रोलाइट हैज अ मच हायर कॉन्सेंट्रेशन ऑफ अ पर्टिकुलर आयन, मैंने एक इलेक्ट्रोलाइट लिया है जिसमें बहुत ज़्यादा कॉन्सेंट्रेशन है एक पर्टिकुलर आयन का, तो वही आयन जो है वो रेलिवेंट इलेक्ट्रोड में प्रेफरेंस में डिस्चार्ज होगा टू दोज आयन जिसका जो कॉन्सेंट्रेशन है उस इलेक्ट्रोड में वो लोअर है. ठीक है, फॉर एग्जाम्पल हम देख लेते हैं कॉन्सेंट्रेटेड NaCl प्लस का सोल्यूशन का. अगर हम देख लें कॉन्सेंट्रेटेड NaCl प्लस NaCl बोल दूँ मैं, NaCl सोल्यूशन का अगर मैं इलेक्ट्रोलिसिस आपको दिखाऊँ, कॉन्सेंट्रेटेड NaCl सोल्यूशन का इलेक्ट्रोलाइसिस. सो हम क्या देखेंगे? फर्स्ट हम देखेंगे आयनिक इक्वेशन क्या बन रहा है. आयनिक इक्वेशन बन रहा है NaCl गिविंग मी Na प्लस प्लस Cl, अरे NaCl will be the one that's giving me Na plus plus Cl minus, and H2O भी है वहाँ पे पानी में, so H plus plus H minus, right? तो at cathode फिर से at cathode, so this is my ionic equation, this is second at cathode वाला चीज़. अब देखो हमारे cations कितने हैं? Na and H, so Na plus and H plus migrate to cathode, but despite high concentration of Na plus, H plus gains electron more acidly. मतलब देखो H plus जो होगा, Na plus ज़्यादा है नंबर में, बट H plus इलेक्ट्रॉन गेन कर लेगा क्योंकि H plus इलेक्ट्रोकेमिकल सीरीज में ज़्यादा नीचे आता है, राइट? सो H plus इलेक्ट्रॉन लेगा और H बनेगा, बट देखो H अकेले रह नहीं सकता, तो H plus H2 हो जाएगा गैस. सो ओवरऑल हाइड्रोजन गैस बन जाएगा. तो हम लिख सकते हैं 2H प्लस प्लस 2 इलेक्ट्रॉन्स गिव्स H2. अच्छा, ये हो गया हमारा एट एनोड वाला. एट कैथोड देखो हमारा एट एनोड करना है, एट कैथोड हो गया. वी हैव Cl माइनस एंड OH माइनस, सो बोथ Cl माइनस एंड OH माइनस माइग्रेट टूवर्ड्स कैथोड टू एनोड बोल रहे हैं, बट क्योंकि concentration of Cl minus is much higher than OH minus, Cl minus is discharged, although OH minus is a lower position. ठीक है, आप समझ सकते हैं. देखो पहले वाले कैथोड में क्या हुआ, डिस्पाइट हाई कॉन्सेंट्रेशन, यस Na प्लस का ज़्यादा कॉन्सेंट्रेशन है, बट जो H प्लस है वो इलेक्ट्रॉन्स ज़्यादा बहुत ही ज़्यादा गेन कर लेता है ईजीली एज कम्पेयर टू sodium, right? So it's a H plus ions that will accept the electrons. But in the case of Cl minus and OH minus ions, even though OH minus is lower in the electrochemical series, Cl minus is discharged because concentration of Cl minus is much higher than that of OH minus. Okay, that is it. This is the example. So if it has, an electrolyte has more concentration of a particular kind of an ion, then that will only get discharged. So what will happen is Cl minus plus electrons, minus electrons, because it had gained an electron only. Cl cannot live alone, Cl plus Cl2. Okay, nature of electrodes used, that is also very very important. तो देखो इलेक्ट्रोड्स ना दो टाइप के होते हैं, वन इज एक्टिव इलेक्ट्रोड, वन इज इनर्ट इलेक्ट्रोड. So electrodes that's used in electrolysis is basically either inert or they are active. Inert electrodes are the ones which do not themselves take part in the electrolysis reaction. Active electrodes are the ones which themselves they take place in the electrolytic reaction. Active electrode example in our syllabus is graphite and platinum, while inert electrode, graphite and platinum. While if you ask me to give an example of active electrode, it's copper, nickel, silver. Okay, these they also take place in the electrolytic reaction. For example, in the reaction of copper sulfate, right, if an active electrode of copper is used, then copper atom is deposited at the cathode and copper ions are formed at the anode. That we'll discuss further also when we'll be entering the discussion of different kinds of electrolysis. In the next video we'll be discussing about examples of electrolysis. I'll be speaking about electrolysis of molten lead bromide, aqueous copper sulfate solution and distilled water. And I'll also be covering some applications of electrolysis, that is electroplating, electrorefining and electrometallurgy. At that time I'll be discussing with you guys that what are the एक्टिव एंड इनर्ट इलेक्ट्रोड्स में डिफरेंस क्या होता है. बट देखो जो इनर्ट इलेक्ट्रोड्स होते हैं लाइक ग्रेफाइट एंड प्लैटिनम, दे विल नॉट टेक पार्ट इन द इलेक्ट्रोलाइटिक रिएक्शन. सो प्लीज राइट दैट डाउन. दे डू नॉट टेक पार्ट in electrolytic reaction, the inert electrodes like graphite and platinum, but the active electrodes like copper, nickel, silver, they take part in the electrolytic reaction, take part in the electrolytic reaction also. Okay. So example, in the electrolysis of copper sulfate solution. Now you can do the electrolysis of copper sulfate solution by using an active electrode copper also, or you could also use an inert electrode platinum. If you're using a copper electrode and when you're using an active inert electrode platinum, the results are different. Okay, if then active electrode is used, copper is used, active electrode is used, then at the cathode you will see a deposition of copper atom. At the cathode, copper atom is deposited and copper ions will be formed at the anode. But if you're using inert electrode platinum for electrolysis of copper sulfate solution instead of Cu2 plus, then you will see that at the anode oxygen has been formed. नहीं तो cathode पे आपको copper atom deposition दिखेगी and anode पे copper ions दिखेंगे if active electrode copper is used. Okay, till this much I will keep today's video. In the next video we'll be discussing about 3 examples of this one electrolysis, that is number 1 molten lead bromide के साथ. Number 2 we'll be discussing acidified water using platinum electrodes, and number 3 we'll be discussing the electrolysis of copper sulfate solution with both a platinum anode, that's an inert anode, or we can also discuss with a active electrode, that's copper. Okay, that's what we'll be discussing in the next video. And then we'll also discuss the first we'll discuss the electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode. Okay, that is it. And then we will discuss the electrolysis of aqueous copper sulfate using copper electrodes. That is it. And then we will discuss 2-3 applications of electrolysis, that is electroplating with metals, electrorefining with metals and extraction of metals, that is electrometallurgy. These are the topics that we are left to discuss and we will cover all of them in the next video. Till then, bye bye, tata.